Why don't we just not buy them anything?
Good job.
I can't afford anything, so I
Eat a
watch
bunch
it
of
box.
food and forget about
Characters
presents.
wait another day of life.
Under probability, like this is the umpteenth thousandth time we've talked about this, just know you've got two different types of probability. You've got the ones that are independent, and you've got the ones that are dependent. Independent means one thing has nothing to do with it. The first event has nothing to do with the second event. For example, the probability of you flipping a head, and then taking a spinner and spinning a 3. But you have to know a couple things here. You've got your little coin. Here's Mr. Abe Lincoln. And you've got a spinner. Let's just say the spinner is cutting the 1, 2, 3, 4. Flipping your head will not change the probability of your spinner. They are both independent of each other. And it's just, when this happens, you just multiply the two together. Probability of getting a head is 1/2. Probability of spinning a 3 is 1/4. Probability of both of those happening is 1/8. It's just that easy. 1 out of 8 times you'll get that. Dependent then is, on the other hand, is the first thing does change the second thing. First event changes the second event. In other words, let's just say if I asked you the probability of pulling 2 boys, let's say we're doing our little Yankee swap, the probability of you picking a boy and then a boy out of the class, okay, because when you pull that first boy out of the class, it takes a boy out of the class and it takes a total number out, it's going to change the probability of that second event happening. How many boys are there? It's 8 12s, right? 8 out of 12, if you pull that first one, but the next one, there's not 8 boys nor are there 12 people left, it then changes to 7 boys left out of 11 for that to happen. So the probability of that happening, well, let's reduce this first, what is that, 2/3, is 14 out of 33, getting 2 boys. Which means the probability of drawing 2 girls, do you think the probability of drawing 2 girls would be 19 out of 33? Wouldn't it be the opposite of that? Wouldn't it be the complement of that? Is it? You would think it would be, wouldn't it? Wait, that seems logical, doesn't it? No, because that would be if there was only 2 choices of getting all boys or all girls. Girls would be what? There's 4 out of 12, and then there would be 3 out of 11. So this changes to 1/3. It's actually 3 out of 33. Wait, which makes it 1 out of 11. Is that what somebody said? And then what would be all the probabilities in between that would be the probability of picking a boy or a girl, or a girl and a boy. Which is a little more on that. Oh boy. And then sometimes the book talks about sometimes you have to make a tree diagram. And just so you know what that looks like, occasionally that helps. You know, like the probability of getting a head, a tail, and then a head. Sometimes it helps you to draw a tree diagram, which is this. So you're actually flipping 3 times. So on the first flip, what do you get? You can get a head or a tail. On the second flip, off of each one of those, you can get a head or a tail. And then on the third flip, off of each one of those, you can get a head and a tail. So this just kind of shows you all of your different combinations of this. And what would they look like? Well, here's how it goes. You can go head, 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 or you could go head, head, tail. You could go head, tail, head, or you can go head, tail, tail. You go tail, head, head, or you go tail, head, tail, or you could go tail, tail, head, or you could go tail, tail, tail. Which means how many different combinations? 1, 2, 3, 4, 5, 6, 7, 8. What is the probability of getting a head, tail, head?
1/8.
1/8. Now, what would be the probability of getting 2 heads and a tail? That would be different, because this one's order specific, head, tail, head. But if I said just getting 2 heads and a tail, you could look at this and go, well, here's 2 heads and a tail. Here's 2 heads and a tail. Here's 2 heads and a tail. I guess that's it. So you'd end up with what?
3/8.
3/8. That's your probability for that. That's enough of that. And then last but not least, last but not least, see if I get an email firing up here. 5, 4, 3, 2, 1.
What do we find out?
5, 6, 2, 2/3.
I'm looking to see what we have here. 2/3. Oh, and then take out a blank piece of paper. This will be fast. One more just to write this so you have it under the notes there. What is the difference between probability and odds? Do you remember that from last go around?
I'm somewhat.
When you go bet on the ponies, that's odds. How is that different?
What?
Or you go to Vegas and they give you the odds. It's related to probability, but it's different than probability. Odds is the ratio of favorable to unfavorable. Which is different than probability. Probability is the ratio of favorable to total. The odds, here, let's say you've got a spinner, and this spinner is split into, let's go 8, just to mix it up a little bit. 1, 2, 3, 4, 5, 6, 7, 8. The odds of spinning a 3 would be, how many 3s are there? 1. And then you put the little colon because that's what we usually do for ratio. 1 to how many not 3s are on here?
7.
7. The probability is 1/8. The odds are 1/7. Let's see, what if they ask another odds? You got 6 red, 2 yellow, and 1 blue. 6 red marbles, 2 yellow, 1 blue. What's the odds of drawing a red? Well, 6 reds to how many not reds?
3.
3, and you'd reduce that. What is it, half of that? 3 to 1? Somehow that works better with the payout. I don't know if that means, I'm not sure how the payouts work. You pay $3, you get 1 if you win.
Wouldn't it be 2 to 1?
Yeah.
It is 2 to 1. I was just checking to see if Carter was looking. How many people thought that? But just didn't want to make me
I
feel
was
bad.
thinking,
I was
2 to 1. Thank goodness for the thinkers. We'll put it in.
that's not my job.
Wait, did you say it's not your job?
That's not my job.
It's not mine. All right. What's the time on the clock here?